it is really inspirational, right? So people say, why do you climb a mountain? Because it's there. Why do we explore space? Because it is the unknown. It basically says why we are here by answering that question. So I just can't think of a better way to bring everybody up, to bring education and science to the forefront of the national conversation. And I think India already has a society which is very much focused on science and engineering. So it's only natural that it would progress into the space sector as well. So I'm very pleased, and I'm very proud of everyone back home and everyone at ISRO. And it's an amazing thing to see these two missions happening so close together.
Hi, you're watching Hindustan Times. I'm Aditi Prasad, and with me is Dr. Anita Sen Gupta, an American aerospace engineer, a former NASA scientist. For me, that's all way beyond my understanding of space science, so to speak. But we are here to talk to her about India's very ambitious the Aditya L1 mission. After successfully landing on the moon just a couple of weeks ago with Chandrayaan-3, ISRO, the Indian Space Research Organization, has now successfully launched Aditya L1 mission to study the sun. The project director said it's like a dream come true for him. The ISRO project director for the Aditya L1 launch. I want to ask Dr. Anita Sen Gupta, what does this mean for space scientists across the world? What does this mission mean for you, this mission to understand the sun?
So the sun is obviously the center of our solar system, and it is the basis for weather here on Earth, and it's the basis for all of the space phenomena that we see in our solar system. So having access to the suite of scientific instruments which are on board this solar observatory is going to give huge insight into the physics of the sun, and that benefits obviously the Indian Space Agency, but it benefits space scientists across the world.
Did you expect India to be the next country to reach for the sun, or did that come as a surprise?
Oh, I'm not surprised at all. I think that the Indian Space Agency and the Indian people have an incredible launch vehicle capability. They've obviously sent an orbiter to Mars, landed a rover on the moon. So it's natural that they would be progressing into all aspects of space science, and heliophysics is an incredibly important element of space science. And I know several Indian heliophysicists as well. So I know it's an area of interest in the community within India.
Right. In fact, I was speaking to several people in America. I think this was during Prime Minister Narendra Modi's visit to the US a few months ago. And what came across is that many of the people, while they appreciated the fact that the Indian Prime Minister was in the US and was being given a royal treatment by Biden, many of those people were not very familiar with India's prowess in the field of space. They were not. That is why my question to you about was there a surprise element? So you obviously have some Indian origin somewhere, as your name reflects. But so clearly you know ancestor in the field. But in general, what is the view about India reaching for the sun in the international community? And especially in your community that you interact with closely?
Yes, I've been to ISRO twice. I've been to the site in Bangalore, and I went to two sites in Bangalore actually to give lectures. And I used to work for NASA's Jet Propulsion Laboratory, so we had already partnerships with the Indian Space Agency in terms of providing sophisticated scientific payloads. And we even had a mission concept proposal where we were working together for a lunar lander mission. So I think the space community is well aware of the Indian Space Agency is what they're capable of. So probably maybe it's more on the global stage. Not everyone pays as much attention to space exploration, and obviously everyone has familiarity with the NASA, the U.S. Space Agency. So it's really more, I think, about getting the word out. And clearly, the world was watching on the lunar landing, and obviously now the rover moving on the surface of the moon. So it was, I think that's where social media comes in, and I think that's where doing broadcasts comes in, so we can bring in more visibility into the Indian Space Agency and the India-specific missions that are already happening.
Right. In terms of the number of countries that have launched similar missions, which are the other countries that have launched similar missions to study the sun, like ISRO? I mean, there must be a handful. Count it. You can count them on your fingers, perhaps.
Yeah, there are very few, and there is a NASA observatory, which I think is parked in the same L1 Lagrange point, making measurements in that region. But of course, with each mission comes new space measurements that can be made, new scientific payloads, and in general, the scientific community enjoys sharing data between each other, right? Because the more data you collect on the sun and the interior structure of the sun and the behaviors and the phenomena within the sun, the better everybody's computational models of the sun can become. So it really is about working together to collect more and more information so that we can all be informed. And the reason for that is the sun impacts our weather, it impacts space weather, which then impacts telecommunications, right, by a satellite. So it's important to all of us across the world to understand the sun's behavior, to be able to predict the sun's behavior better. So I like the fact, I think that all space exploration should be international collaborations.
Right. Oh, what about of course, the scientists, many of the experts that we've spoken to, they've talked about how this is a pioneering leap to study the sun. You obviously know about the entire program, the scientific reasons, the mission for the study. Could you sort of shed light to us on why is it a pioneering leap if there is NASA and there's a European Space Agency already doing a similar thing?
Well, so every mission collects another piece of data. So when there's another mission that comes around, whether it's another NASA mission, ESA mission, or ISRO mission, they're going to collect new data, whether it's data that's never been collected before or collected in a way where you can understand it better because you have higher resolution, a longer accuracy. In the case of this mission, it's collecting, solar wind information, particles. It's kind of not just remote sensing of the sun, but it's also particle experiments. So when you make those types of measurements, you just get much better scientific data, much better engineering data, which helps you understand a model for the behavior of the sun. So every mission adds to the next mission, but this has 7 total payloads. That's a lot of science which is going to be collected, and it's going to be there for many, many years in that wonderful spot to constantly observe the sun. So I think the right way to look at it is that it adds to the existing knowledge, but in a huge way because of the number of scientific payloads and the sophistication of those scientific payloads, because obviously this mission was just launched. So it reflects the latest of the greatest in measurement technology, whether it's in the X-ray spectrum or whether it's in imaging technology or if it's looking at particles of the solar wind, for example.
Right. What we understand that this mission with all the 7 payloads, was developed completely indigenously by India. What does this mean for India's global heft as far as space exploration, as far as space science is concerned?
Well, I mean, it goes to show that they are one of the major players in space exploration across the world. And I think couple that to the launch vehicle capability and the orbiter capability, it's kind of a complete ability to do everything on the international stage when it comes to space exploration. And ultimately, that's what I've always hoped to see, that we have a global space community, because when we go to the moon, when we go beyond, when we have human presence in space beyond, where we're at now, which is in low Earth orbit, that's going to be a global challenge. That's going to have global participants. It's going to have funding from agencies across the world. So this kind of is where I think we want everybody to go with their space programs, is working together. So yeah, I just can't, it's a wonderful thing. And I think in general, solar physics is probably one of the most important areas to focus on because it affects everything in the solar system, right? The solar system was formed because of the sun. Everything that we experience here on Earth in terms of our environment, right, is because of changes in dynamics in the sun, in addition to, of course, anthropogenic emissions that we have to deal with. So being able to understand changes in the solar aspect of weather as compared to changes in the weather due to things that we're doing here on Earth, we can't answer those questions unless we make these measurements.
How do you, India has also recently opened up its space sector to private players. How is that going to add to the entire boost that the entire space exploration sector is about to receive, and also not just within India, but globally?
Yeah, so having a commercial space sector is key because that enables continual investment, it enables competition, it enables efficiency, it enables finding business cases to say, how are we going to use space? And clearly there's an obvious use case for space from a business perspective, which is telecommunications, but there's things beyond that, right? And having an affordable launch capability, having an affordable suite of orbiter capability, spacecraft bus capability, couples to having a healthier space sector. And ultimately what that leads to is an economic boom, right? It creates more jobs. And I think what's really important to me as an educator, because I'm also a professor, is it really does inspire the next generation of young people to become scientists and engineers because they become excited by the findings from space exploration like this mission.
And I think I agree with you because the kind of interest, not just Chandrayaan, but Adityal1, both these events, both these launches by ISRO within weeks of each other, have sort of, there's so much of interest. I mean, one never knew that there was so much of interest in space as far as Indians are concerned. The only thing you hear about and talk about and people are talking about seems to be Chandrayaan 3 and now Aditya1. So yes, and in terms of far as boosting the scientific tempers of the youth is concerned, it will, I'm hoping, go a long way to boost that.
Yeah, it is really inspirational, right? So people say, why do you climb a mountain? Because it's there. Why do we explore space? Because it is the unknown. It basically says why we are here by answering that question. So I just can't think of a better way to bring everybody up, to bring education and science to the forefront of the national conversation. And I think India already has a society which is very much focused on science and engineering. So it's only natural that it would progress into the space sector as well. So I'm very pleased and I'm very proud of everyone back home and everyone at ISRO. And it's an amazing thing to see these two missions happening so close together.
And you obviously have some Indian antecedents, in you. You want to talk about that with us? And because of those Indian antecedents that you have, do you feel a special pride in the fact that India has sort of joined this select club of nations who are now doing, part of this mission to study the sun?
Well, of course. I mean, my father was Indian. My family lives in Mumbai and they live in Kolkata. So I was just there recently, actually, for several weeks back in March, doing talks at ISRO and at different universities. So I really do enjoy being able to come back to India, visit my family, and share kind of my visions of space exploration. And being able to combine that with indigenous space exploration is kind of the most amazing thing. So it makes me really happy and really proud as an Indian woman based in the United States to be able to share with people here, because I actually, in my class that I teach at USC, I'm now including all of the latest results coming from Chandrayaan as well as Aditya, right? So now I can include in my suite of spacecraft that I talk about with my students also the Indian capabilities that are out there. And that makes me really proud as well, as you might have mentioned.
Makes us all proud. Thank you so much for joining us.